These are what you call the real world probability, something that you observe from the market. But you want to replace them with something else which is called the risk-nuetral probabilities. So if this is the case, then I'm saying that there exists a Q between 0 and 1 such that this 1 plus R S naught, okay, can be written as Q times of S1 of U, for example, and plus 1 minus Q times of S1 of U. Okay? And S naught, can I write S naught as Q1, S1 bar of U, and 1 minus Q, S1 bar of D, where this S1 bar is always going to mean, and S1 bar of omega is going to mean S1 of omega divided by 1 plus R, and this is sometimes called discounted stock price. Discounted stock price. Agree? So, since the Q are between 0 and 1, there exists because of convexity. So, since Q is between 0 and 1, I can treat them as probabilities, right? So, if this is probability, what does this guy is? We think about this term. This is basically expectation of S1 bar. Random variable S1 bar with respect to the probability, risk-nuetral probability Q, where the Q is Q1, Q2. What's an expectation? Imagine I have a random variable which takes two values, okay, 1 and 0, with the probability P and 1 minus P. So what is going to be the expectation? We're going to say, okay, multiply value with the probability and add them. So what I'm saying is that now instead of S0, S1 U and S1 D, replace in this model Q and 1 minus Q. So for S1 I can have two possible values with these probabilities. So if I multiply with their corresponding probabilities and add them, I'm going to get the expectation. Let me formally write what I have done. Basically, I have reformulated the first condition that we have, an massively insufficient condition that we have for so just think about it. This condition is equivalent to this condition. Isn't it? So if this is true, then this must be true. And this is true for this side. So they are equivalent to each other. In other words, since we were saying that the model is viable if this is true, I'm going to say the model is viable if this is true. So I'm going to say a model is viable if and only if there exists Q, and it is going to always exist, which is Q and 1 minus Q, probability measure, that's a probability measure, Q, such that the expectation of S1 bar is same as S1. Okay. Now here the key thing is that do we have Q now? Okay, that's what we have to basically find. And once you have Q, okay, then you can do pricing. Now, how can I price a derivative? Quickly, pricing. Okay. With risk-nuetral probability. With risk-nuetral probability. So it's now pretty much simple. Y is going to be pretty much simple. It's going to be E insights, which is going to be the connection. This is going to help us with. The answer is this. The fair price of the derivative is going to be this. Is going to be that with this risk-neutral expectation, that with risk-neutral probabilities, compute the expected value of Let me tell you something about discounting. So, if I want to find the future value, just think about it. When I have a B naught with me, I'm multiplying it with 1 plus R. So it's giving me what? The future value of B naught. What if I divide B1 by 1 plus R? So in other words, I'm discounting 1. So in other words, I am trying to find the value of this B1 at time 0. Okay. So here I can write EQ of B divided by 1 minus R. You can write it like that. Since 1 over 1 plus R is a number, so I can insert it here. The number can be put inside the expectation value. So I can write it like that. Okay. Now, why that's a very sensible formula? Just think about it. So I have a payoff which I'm expecting in the future, and I'm discounting it. So when I'm discounting it, I'm doing what? I'm going back basically. I'm computing its past values. We call it initial value. Okay. So future value and present value. Okay. So what should be the price of the derivative at time 0? It should be that what is the expected D bar. Just think about it. So D is what? D is the value at time 1 of the derivative at time 1. You discount it, so it's going to be value at time 0. Roughly, just giving you a sketch actually. So when you are computing expected value of D bar, you are computing the expected value of D bar at time 0. And we are saying that it should be equal to what? The price of the derivative. So the expected value of the derivative should equal to what? And why this should be true? This should be true very easily. Think about it. Because we know that this is true. Okay? So if I take the expectation of this guy, I'm going to get the expectation of this guy. Okay. Now what is going to be the expectation of this guy? So it's going to be x b1 plus so EQ of x b1 plus y s1. Okay, if I have a bar here, I'm going to have a bar here. In other words, if I'm dividing here by 1 plus r, I'm going to divide here by 1 plus r. Okay? So I have divided by s1 of omega 1 plus r is equal to what? EQ of d bar of omega. Agreed? I have this. Now, if I simplify it further, that's a deterministic thing. There is no randomness here. So it's going to stay same. And when b1 is divided by 1 plus r, so it's going to be beta. So y is a number, I can pull it out, and I'm going to have EQ of s1 bar of omega. EQ of beta. Okay. Now what is EQ of s1 bar of omega? That's your s naught. x p naught plus y s naught equal to dq of t bar. But that's my part.
By replicating.
Okay. Now, how to practically compute the last? Really the last. So step one, computations. Are you going to do the computations? First, we need to compute this basically, q and y minus n. How can I compute it? I'm going to compute it from my necessary and sufficient condition for non-existence of arbitrage, the viability of model, which is this equation. Just think about it. So if I write this explicitly, what would be this? So it's going to be S naught Q S1 bar of U plus 1 minus Q S1 bar of DL. Okay? Are you getting the point? So can I compute it Q from here? So I know S naught, I know my interest rate, and I know my S1U and S1D. I can just substitute the value. And once I have Q, then this result is telling you what? You know the payoff, discount it, and compute its expected value using your Q and the price. Okay? So that's it. I mean, we almost covered the chapter actually. That's a rough idea. So there are two approaches. Number one, either you find a replicating portfolio which agrees with the price of derivative at time 1, then it's going to agree with the price of derivative at time 0. Or you find risk-neutral probabilities and directly compute the expectation of the derivative, and it's going to give you that. Okay. One last mystery. Why you are calling it risk-neutral probabilities? Why they are risk-neutral? I mean, we haven't seen yet any neutrality of risk here. Okay? The neutrality of risk is this. Compute the expected value of the returns on the portfolio with respect to this. Okay. Compute the expected value, for example, on a stock action. On when you're only investing in the stock. So it's going to be what? So it's going to be EQ of, are you going to compute? So it's going to be S1 of omega minus S naught over what? S naught. Okay, I can discount it as well. I can discount it as well. So in other words, I can divide by 1 plus S naught. It's going to make any difference? From discount. See that's basically. Now, I'm going to do what? I'm going to do, for example, 1 plus R, multiplying 1 plus R and dividing 1 plus R here. So if this is the case, what are you going to have? Okay. So S naught is a number, so S naught is going to come here. So I'm going to have expectation of S1 omega minus S naught. What is expectation of S1 omega? So it's S naught 1 plus R minus S1. Agree? You can get it from here. You can get it from here. So what do you have? S naught get cancelled. And sorry, it should be like this. I can do it. Is it going to be divided or multiplied?
Multiplied.
Okay. Okay. We're not going to have this. Let me write it. That's really right. Don't clear in this. E cube of R on short, that's what I'm going to do. And it's going to be E cube of S1 minus S0 over S0. Okay. So it's going to be 1 over S0 times E cube of S1, which is going to be 1 plus R S0 minus S0. Agree? So S0, oh, okay, I'm going to have a minus 1 here. S0 will get cancelled with S0. I'm going to have, okay. Now, why that's a miracle? That's a miracle. Really miracle. So, what I'm saying, that the return, expected return on stock, which is random, completely random. Expected returns on stock, which is random, is equal to what? Something becomes. So it's getting rid of the risk factor. Isn't it? Just think about it. So you have a randomness here, and with respect to this probability measure, you are computing expectation, and something happens which gets rid of the risk, and you get what? The risk-free returns, right? Therefore, you will call it, that's a risk-neutral probability. Why? Because they are neutralizing the risk. Right? Okay. Finish this up as soon as possible. And spend time on this. Do exercises, spend time on this. Okay. Continuing this. Because if you understood this, that's just peanuts. Good to just generalize that. Okay.